Hi guys, this is my teach one on data cleaning um, for HAP 671 with Professor Avramovic at George Mason University. So why do we need to clean our data? Proper data cleaning is essential to having a good SQL code to work with in any project. It's the most important part of the machine learning process because it does so many things to your data behind the scenes, like that purify it and remove all the things that could cause problems later on in your project. For example, it removes unwanted observations like duplicates and irrelevant data. It removes structural errors like if you have n slash a and na, and those are for not available, then it just converts all of them to n slash a. And it filters unwanted outliers in your data. It handles missing data, like dropping and imputing the missing data, which can be categorical or numerical. An example for categorical data is it adds a new category. And an example for missing numerical data is it imputes using 0, the mean, or the median. Why do we need to clean our data? Continued. This is why we remove duplicated data, zombies and unborns, which are visits after death for zombies and visits prior to birth for unborns, patient visits with unusual dates, all complications of treatment, and only keep diagnoses that are okay before treatment was given. This is all prepping the data for analysis, and if the data cleaning step is skipped, you'll get errors in your code and data, as well as inaccurate results. So um, this is the first part of the data cleaning, and it has the code and the meaning behind it. So the first step is to remove duplicated data, and I did that with select ID, ICD-9, AGET diagnosis, AGET first DM, AGET death into a temp table called no duplicate from dbo.final, grouped by the same things that I selected, the same columns that I selected. Um, so we're removing duplicates for the same patient, same diagnosis, reported on the same date via group by. If there's multiple entries for diagnosis of a patient at a certain age, only one will be kept. And the next step is to remove zombies and unborns. So that's selecting all the columns in the DBO final and putting it into a temp table called non-Z. And this is grouped by all the columns and having age at death, the minimum age at death greater than or equal to the max age at diagnosis, or the minimum age at death is null and minimum age at diagnosis is greater than 0. So for removing zombies and unborn, often the data has an incorrectly entered date of death that shows this date is prior to visits. This would make sense um, for some healthcare services performed after a patient's death, like autopsy, but multiple and repeated outpatient and inpatient visits after a date of death shows there's a problem with that date. In this part of the code, but that's in the red brackets, um, date of death is checked by making sure the patient's reported minimum age of death is higher than the max age of diagnosis. We also allow patients who have a null value for age at death, which means they haven't died, to be included in the clean data. The last part of that code checks the date of birth by requiring that the minimum age at diagnosis be greater than 0. Next, we remove visits with unusual dates. So remove patient visits with unusual dates. Select all 5 columns in the dbo.final into a temp table called in range, where age at diagnosis between 18 and 105 and age at diagnosis is not null. So where age at diagnosis between 18 and 105 checks if the age at diagnosis is between 18 and 105 years old. The code after that and age at diagnosis is not null excludes missing date entries. By using select ID, comma, visit ID, we're only keeping those visits and related diagnoses that meet both criteria, which eliminates a portion of the patient record that has an out of range or missing value. This is why we need to keep both the patient ID and visit ID. Next, we remove inconsistent data, which is removing patient visits with unusual dates, and that's for data that doesn't make sense, like select ID from dbo.data where not gender equals male and pregnant equals yes. So we're only keeping patients which are not pregnant males. Next, we are removing complications. Um, Moving patient visits with unusual dates. Um, Select ID diagnosis from dbo.data where age at diagnosis is less than or equal to age at treatment. Group by ID and diagnosis. We drop diagnoses that occurred after treatment. In this code, we remove complications of treatment and retain all diagnoses that occurred before or at the time of treatment. Where states the diagnosis age should be less than or equal to the age at the start of the treatment. Next, we check if the date of birth is in error and if you have visits after date of death or before birth. So, and this is part 2 in the data cleaning. So in the first 2 queries, we're deleting all data that has errors in it. Date of birth might be an error and have visits after date of death or before birth, date of birth. So select distinct ID from dbo.l underscore cancer. That was the database I was using in my HAP 464 class that I got this code from. Group by ID having max age at diagnosis is greater than the minimum age at death. And then we delete that code from above. So delete from dbo.l underscore cancer where ID and then it's that same code as above. Um, then we remove diagnoses for patients whose age of diagnosis is null. So remove, so delete from group diagnosis 2 where ID and select ID from group diagnosis 2 where age at diagnosis is null. Next, we aggregate patient diagnoses based on age at diagnosis of 55. Select distinct ID into temporary table called T55 from group DX2 where try convert decimal age at diagnosis is less than 55. Select um, all the columns in the group diagnosis 2 into all diagnosis 2 from group diagnosis 2 and inner join the temp table T55 on group diagnosis 2.id equals hashtag T55.id. Then last we find repeated diagnosis. To find a repeated diagnosis, you do select ID, ICD-9, age at diagnosis, age of death, row number, over, partition by ID and ICD-9, ordered by age at diagnosis as repeated ICD-9 into temporary table rank temp from all DX2. Select and then you select the top 10 from rank temp and order by ID, ICD-9, age at diagnosis, and repeated ICD-9. And these are my references. It's just my Project One code and Project One paper assignments from the HAP 464 class I took in undergrad, which was this past spring 2020 semester with Professor Alemi. Thank you, and I hope you learned something from my each one. Thank you.